Korean athletes dominated the short track events at the 2025 Harbin Asian Winter Games, securing 6 gold, 4 silver, and 3 bronze medals, their best ever performance in the competition's history. Short track speed skating demands a mix of strategy, technique, and endurance. Skaters must outmaneuver opponents, master tight cornering, and maintain stamina throughout the race. With frequent curves and the powerful pull of centrifugal force, success in the sport relies heavily on scientific analysis. Today, let's learn about the science and technology behind the short track. Centrifugal force, the key to short track success and the technology to overcome it. Although both are forms of speed skating, short track differs from long track in its focus. While long track is about racing against time, short track is shaped by curves that make up half of the 111.12-meter track. Centrifugal force is the apparent force that pushes an object outward when it moves in a circle. It happens because of inertia, which is the tendency of an object to resist changes in its motion as it rotates around the center of the circle. Have you ever been in a car and felt your body drift outward while turning a curve? That is a centrifugal force. It's not a real force that exists, but an imaginary force that occurs in rotational motion due to the law of inertia, the tendency of an object to maintain its original state of motion, given that all forces acting on the object are zero. Short track athletes experience centrifugal force on curved race tracks, which interferes with their cornering, the art of turning corners smoothly and quickly to keep on skating. Short track athletes train against centrifugal force, and the most crucial skill is to create centripetal force, which is the opposite of centrifugal force. The centripetal force works in the opposite direction of centrifugal force, and athletes create the former by leaning in the opposite direction of the latter, adding their own weight and the force of their skate blades, pushing against the ice friction. This is why short track athletes lean on their hands and almost lie on the ground around the corner, which is the cornering technique in the event. The blades of short track skates are also designed to reduce centrifugal force when cornering, with the blade's center attached to the inside of the sole rather than the center. The blade is also curved to the left in the direction of cornering, and it is slightly convex toward the ground, designed so that the skate can dash out even after turning a tight curve. In short track, athletes often lean heavily to the side, causing their shoes to come into direct contact with the ice. To accommodate this, the distance between the blade and the shoe is increased by 2 to 7 millimeters. A skater's height also plays a crucial role. If they're too tall, it's harder to maintain their center of gravity, which can lead to being knocked off track. Conversely, if they're too short, reaching high speeds becomes difficult. Therefore, the ideal height for a short track athlete is between 165 and 175 centimeters.